Question 1 says, look at triangle A. Says, how would you describe its sides? This is triangle A here. I see that all three sides have measurements of 4 centimeters. We're going to take our time and answer 1. 2 says, what kind of angles does triangle A have? So what type of angles? If I know they all have the same lengths on sides, what type of angles would they have? 3 says, what are the 2 names of triangle A? What can we call it according to its angles as well as its sides? And for 4 says, what are the 2 names for triangle B according to its sides and according to its angles? Let's pause and give it a thought. For B, we see that it has 3 different sides for its lengths, so we know its angles would all be different also. For 1, we can see that triangle A has 3 equal sides. That's how we can describe the sides. They're 3 equal, 4 centimeters, 4 centimeters, 4 centimeters. It says, what kind of angles do we see here? We see that because it has all acute angles, there's going to be 3 acute angles here. They're all going to be the same size or the same angle because the sides are also all the same. It says, what are the 2 names for our triangle? Because all of the sides are the same, this is going to be an equilateral triangle. And because all of the angles are acute, this is going to be an acute triangle. Next, for 4, it says, number 4 says, what are the 2 names of triangle B? And explain. For B, we see that none of the sides are equal. Therefore, it's going to be a scalene triangle. And because all of the angles on this triangle are acute, we see we're going to have an acute triangle. We're now looking at question 5 and 6. For 5, it says, can triangle C be called an acute triangle? We're looking here. So for it to be an acute, we're looking at the angles. Our angles need to be less than 90 degrees. Let's pay attention to this angle here. Next, for 6, it says, how are these triangles alike and how they're different? So you want to see what can we see is common in these 2 triangles, what can we see is different. Let's pause our video and give it a shot. To answer number 5, the answer will be no. Although these 2 angles are both acute angles, this angle here is more than 90 degrees. Therefore, it is a obtuse triangle. Here for 6, it says, how are these triangles alike? We see that because they're both isosceles triangles, these lines on each triangle indicate that they are the same dimensions on each triangle. Therefore, both of them are isosceles triangle. But this triangle is a right triangle. And this triangle is a scalene. We know this is a right because it has one angle that is 90 degrees, indicated by our square. And we know these are acute triangles because they are all 3 of them are less than 90 degrees. Moving on to question 7, it says, look at triangle D and E. Triangle D sides are all different lengths. Triangle E has 2 sides of the same length. Write a letter D or E in the table below for all the possible names of each triangle. So if it's an equilateral triangle, we're going to put our letter there, D or E. If it's isosceles, you put D or E. Take your time and fill in this table. And then move to 8. It says Kelly draws a triangle F with 3 equal sides. She writes F under equilateral and acute in the table in problem 7. Did she forget any possible names for her triangle F? So no, we know that her triangle has all equal sides. That's what we know so far. Now, because it has equal sides, we also know that it would be equal angles. So let's see what we could have also included. For 7, it says which of these is an equilateral? None of these are equilateral because none of the sides are all equal. Isosceles, our lines here indicate that these 2 sides are equal, so E could be an isosceles. Scalene would be D because it doesn't have any lines. It shows us that all of these lines are not the same. We do not have an acute angle because this is obtuse. It's more than 90, but this is 90 degrees. So E will be a right triangle, but because this is more than 90, it will be obtuse. For 8, it said that we had a triangle with all 3 equal sides. So we know that it could be an equilateral because it has all equal sides. It could also be acute because all of the sides are the same. So that means all of the sides will have to be 60 degrees, because it has to equal up to 180. Now, because it has 3 equal sides, we could also call this isosceles triangle because it said it has to have at least 2 equal sides. Because this has 3, it has 3. It has at least a 2, so it could also be called an isosceles triangle. For number 1, we're going to complete each sentence with one of the words from the word bank in order to make the sentence true. So it says an equilateral triangle, blank, has all properties of an isosceles triangle. A right triangle, blank, shares property with an isosceles triangle. And a right triangle, blank, shares properties with an obtuse triangle. So we're going to fill in our blank. Let's take our time here. Use this diagram to help you. It says to look at the Venn diagram and example, describe what is shown about the relationship between acute and equilateral triangles. So we want to look at our acute triangles, which is here, and our equilateral triangles, which is here. Let's pause the video and see if we can answer this. To answer part A, it says an equilateral triangle always has the properties of an isosceles triangle. It says a right triangle will sometimes have properties of an isosceles triangle. And a right triangle never shares properties of an obtuse triangle. We know this because we can start from the bottom. A right triangle has to have a 90 degrees. And if it has an obtuse triangle, that means it will be more than 90 degrees for one of our angles. And we know we can't add a 90 degrees plus anything more than 90 degrees because it will equal more than 180, and we know all of our angles on a triangle should equal 180. For B, it says a right triangle will sometimes have the property of an isosceles triangle. That means we could have a 90-degree angle, but the other 2 angles would be possibly 45 degrees because, well, it would have to be 45 degrees because the other 2 angles have to equal have to have a total amount of 90 to equal with the other 90 to get 180. Here it says an equilateral triangle will always have properties of an isosceles. And this is true because if it is an equilateral triangle, that means it has 3 equal sides. And for it to be isosceles, it has to have at least 2. So that is true. So for 2, it says, look at the Venn diagram, describe the relationship between the acute and our equilateral. Here we can see that our equilateral triangles always have properties of acute. So anytime that it is an equilateral, it is always going to be an acute triangle. All right. Therefore, equilateral triangles always have 3 acute triangles. Equilateral triangles will always have acute. We see the entire circle of our equilateral is inside of our acute. So any equilateral triangle will be a acute triangle. It will also be an isosceles triangle, as you see inside of here. Question 3, it says use the information in the table to fill the tree diagram showing the hierarchy of the following quadrilaterals. We have our parallelograms, squares, rhombuses, trapezoids, and rectangles. Remember, each category in the hierarchy has all the properties of the category below it. So if any of our polygons are below it, that means it also encompasses them. So take your time. Let's read through our properties and see if you can fill this chart in on your own. After, let's move to 4. It says explain what the tree diagram in problem 3 shows about the relationship between our trapezoids and our parallelogram. 5, it says describe a quadrilateral that cannot be placed in the hierarchy under the trapezoids. In 6, it says use the tree diagram in problem 3 to fill in the blank to make the following statements true. You should be able to see them on your own page. It says the opposite sides of a parallelogram are equal. Therefore, the opposite sides of any blank, blank, and blank are equal. Let's take your time. Use this chart to help you fill this out. Take your time. To answer question 3, we want to go through this chart and determine which of these properties of these different polygons are not in the other properties first. If you want to, and that's where we can work this way up. If you want to work from the top, you want to see which of these properties can incorporate all of the different polygons. and as you scratch one off, you would just ask the same question for the remaining. So first, it says it has at least one pair of parallel sides. Because all of these shapes can have at least one pair of parallel sides, we'll put trapezoids next. Next, it says has two pair of parallel sides. Before it said at least one, so we know that would be before this. So next, we would have at least two pair of parallel sides. So a parallelogram will go next. Next, it says our rectangles and our rhombuses, which means we can look at our rectangles has 4 right angles, and this has 4 equal sides. So if it has 4 right angles or 4 equal sides, this is just about the same. We can put those here. And next, we will have our square. Our square will be the next polygon in our hierarchy. Our square shows that it has 4 equal sides and 4 right angles, which incorporates our rectangle and our rhombuses. All right. Next, we go into question 4. It says, explain what the tree diagram in problem 3 shows about the relationship between our trapezoids. So here we see that every property of a trapezoid is also a property of a parallelogram, but because it's up under here, it says that every parallelogram property is not a property of our trapezoid. For our example, it said for our trapezoid, at least one pair of parallel sides. Here, our parallel says it has at least 2 pair. It has 2 pair. So if our trapezoid only has one, then it won't be considered a parallelogram. But because our parallelogram has 2, it can be considered a trapezoid. 5, it says describe a quadrilateral that cannot be placed in the hierarchy under the trapezoid. So therefore, if it can't be placed in our hierarchy under trapezoid, that means it would not have at least one pair of parallel sides. And a good example could be this quadrilateral I drew here. We know it's going to have 4 sides, but none of these sides are going to be parallel. So that's how we know it cannot be in this hierarchy. For 6, it says use the tree diagram for problem 3 to fill in the blank. The opposite sides of a parallelogram are equal. All right. Therefore, the opposite sides of any rectangle, rhombus, or square is what should be placed here, because we know it should be that because it's up under it in the hierarchy, and we know they are also going to be equal. So anything up under it would also encompass itself with the properties. All right. So for the next 2 pages, you will all be answering these on your own. This will be your exit ticket. Make sure you submit with our Nearpod. Make sure you use the sides to show your work.